our secretary Oscar is here. Hello, Oscar. Okay, Daniele, shall we start? I think the
Yes.
time is around 9 a.m. in for UTC time.
Yeah, I think I'm sharing the screen. I see the
Okay.
Mythical.
Yeah.
Okay.
Okay,
Please.
let's start. So yeah, good morning, good afternoon, and good evening for everyone. So welcome to CCAMP session. This is the online meeting, and actually this is our first online meeting, right? Let's start from the next page. Okay, for the loadware, I think you are familiar with the loadware information. It's about the reminder for the IETF policies. So here I still would like to repeat some piece of information, some important piece of information, like it says, by participating in the IETF, you agree to follow IETF policies and IETF process. And if you are aware that any IETF contribution is covered by patents or even patent applications, you must disclose this fact or not, participate in the discussion. And also there are some information about the IETF privacy statement. Please have a look if you would like to get more information from the link on this page. Next, please. Okay, so this meeting, this session, we have 2 hours, and which is 120 minutes. Next, and actually, looking at the agenda, we have only 4 presentations. So with 120 minutes. So I think we should have sufficient time for deep discussion. So anyway, I think we will have some fun on young models for the optical impairment. We see some much discussions on the list. Okay, next.
Yes, just to add, Gert was very kind to put together some slides to bring to the session the discussion that was started on the mailing list, so that we can use the time, the Q&A time, to discuss a little bit about the open issues and maybe poll for consensus and move the work forward. So we will have within a slot 3, we will have 2 presentations.
Yeah, good. Thank you, Daniele. So at this time we are using Mid Echo. So I think we all know how to use the Mid Echo, and if you are going to ask questions or comments, you have to enter session queue. For example, you have to raise your virtual hand, and then the chair will allow you to talk. Next. And for the minute takers, and I think right now we are using Code MD, this kind of online tool to take minutes. So anyone, you could take the minutes, and that will be much appreciated. And for the blue sheets, this will be automatically created. So nothing for us to do, nothing for us to do for the blue sheets. Yeah. For the IPR process, this is quite very important, reminder. And so you know, prior for a document, you know, prior to moving to next step in working group process, for example, before individual draft becomes a working group document or a working group document goes to last call, you know, the chairs will send out IPR polling, and so we encourage you to respond to, you know, IPR polling as soon as possible. Otherwise, it will delay, you know, your work move forward. Next. For the, you know, mailing list, we always encourage people to use the, you know, mailing list as much as possible. Especially we could use the mailing list to introduce some open issues and introduce some new drafts or even some potential new work topics in for the CCAMP. So and also, you know, another reminder is that, you know, working group consensus is determined on the list rather than, you know, on this at this, you know, online meeting or even face-to-face meeting, you know. So you know, actually, if we got some consensus here, we still need to bring this kind of, you know, discussion to the list, you know, to get the, you know, a formal working group consensus. Yeah, next. Okay, it's for you, Daniele. Thank you.
Okay, let's start with a quick recap of the status of the working group. We have two drafts in the ISG processing, the layer 0 types and the Young model for WSAM. None in the editor queue or which recently became an RFC. The tunnel model is expired, but I mean, I guess the reason is waiting on the updates on the Young T. I don't know if the others would like to add something more about the status of the draft, but I assume that it's just waiting on dependencies. Anyone from the others would like to give us an update? I take it as a no. Okay, on the agenda, we have 4 documents on the agenda today. The layer 1 types, layer 1 CSM, the OT, the applicability of GMPLS to the OTN beyond the 100 gigabit, and the optical impairment topology Young model. Actually, we have many more working group documents, but I believe that just a few of them are have a slot requested because we did a quite effective interim meeting between IETF 108 and this one, where we spent quite some time discussing about the layer one documents, and for some of them we requested the Young doctor review, and they are pretty close to working group last call. There is a number of other drafts which will not be presented today. We didn't collect feedbacks or status on most of them, so we would like the mic. We would leave the mic open now to allow the authors to share information about them. So feel free to start in whatever order you feel. We are not following this particular one. There are some drafts that we have not discussed in the last 2 or 3 meetings, and it would be nice to know what's the status, what are the next steps that the authors believe are necessary to progress the work. Anyone?
Just, Daniele, one comment, if you can hear me. It's Gabriele speaking. About the DWDM LMP, interface LMP, and interface parameter Young. Especially the second one will follow the draft on the T topology Young, and today there is not an update to realign this document to the topology, TT topology, but we'll do just after this call, and then we plan to have internal meeting to the group next week.
Okay, very good. Thanks, Gabriele. Okay, let's move to the status of drafts not in agenda, for which we have an update. FlexiGrid Young. There are biweekly calls on this draft. The RBNF info models have been removed, and it has been aligned with RFC 8795. And the layer 0 types. So this is a lot of work has been done on this draft. I personally did the review of the draft, and I believe that it's ready to be moved forward. Given now the fact that the W's on Young and the L0 types are in the ISG processing, this is the natural, let me say, next step in the pipe. Few words on liaisons and communications. We replied to the classical liaison from the ITOT study group 15 on the OTN standardization work plan. This was done back in August. This is the usual liaison to CCAMP, TIS, PCE, MPLS, etc. We received a new, let me say, a new version of the same liaison last month in October. So I mean, this is the classical liaison relationship that we keep on having with the study group 15. As usual, if you would like to review and provide your comments, they are more than welcome. So we are ready to start. Let me pull up the slides for the first slot. And the speaker will be Aomian. Aomian, you are in the queue, but I think you can start your audio directly. Aomian, if you click on the send audio streaming button. You can start your audio automatically.
Excuse me, can you hear me now?
Yes.
Oh, okay, sorry. Okay, so this is Hamian from Huawei, and I'm going to present the update for the Layer 1 CSM Young module. Actually, we are going to update a little bit about the Layer 1 types together. And next, please. Okay, so this is the work we have been updated after our interim in September, and the mainly work we do is to fix the comments in the early Young Doctor review, and we are mainly addressing one comment from especially for the coordination between the math structure with ITU UNI stubs. We also provide some editorial changes in the draft and text description. The Young model can be found in GitHub repository, and there are still open issue list and pull request working on it. Next, please. So now here we introduce what has been done for the coordination between the MEF and ITUT. So in the MEF, there is specification 63 talking about the layer 1 service attributes, and all the connectivity service model is specified in a 3-tuple, including the protocol, the coding function, and the optical interface. While in the ITUT, in the meantime, actually the similar things is defined in a different way, named as the client signal, which is now consistent with layer 1 types. With layer 1 types client signal. So we are trying to use a table to list what is the difference between the MEF and the ITU side on defining the same let's call it client signal temporarily. So for the MEF, there is a 3-tuple. We are using the Giga Ethernet as an example. So for the Giga Ethernet, MEF specifies its protocol as Ethernet, and the coding function is 1000 base X. And for the optical interface, there are a few different options which are specified in the IEEE recommendations, including the SXPMD, RXPMD, and so on. So it's a very kind of detailed specification regarding the details of the Ethernet. But if we look from the perspective of the optic side, so basically we are only consider it as Ethernet 1 gigabits. So this is specified as the ITU side, and we specify it in the as an identity in layer 1 types named as client signal. And so for the same kind of for the same kind of client signal, we are having different representations, and we wish the L1 CSM can support both cases. So here we update our Young tree in the bottom of this page. We are creating 2 cases. So one is for MEF and using the 3-tuple representation, and the other way is ITU, and we use the client signal. And when people consider to is planning to deliver a client signal with a MEF format, it goes into the MEF way, and also the same principle applies to the ITU. Next, please. So accordingly, to make the model work, we also go back and change the layer 1 types. And for the client signal, we are having the common client signal identity from both bases, from the MEF and the ITUT. So there are a list of identities we need to follow up with multiple bases. We are here using the STM1 as an example. So for the ITU cases, it is based on the client signal from the layer 1 types, and in the MEF case, we are having the coding function for the same identities. So we put different reference here, and they are referring to the specification in ITU and the MEF respectively. And in this page, we list all the identities that we introduce the multiple bases, including the STM series with different rate, one for 1664 and 256, and the OC series 3, 12, 48, 192, and 768. And the last one is fiber channel with 100, 200, 400, 800, 1600, and 3200. So that's all the client signal with multiple bases, and we need to take care of them. And all the others are now perfectly fits into the with only a single base. Next, please. So okay, and that's what we have been progressing, and now we still have one open issue, number 72, on the GitHub to maintain the consistent configuration on the PCO. The problem is the problem will occur when people mistakenly configure, for example, STM protocol with Ethernet, for example, optical interface or coding function. So no one is guaranteeing the successful of such configuration. So we need to maybe put more text description in the draft to do this kind of things, or specify some mechanism in the model to make sure that the configuration is consistent. And we also need to coordinate the performance metric part with a few other documents. There has been quite a few related work in different working groups in IETF, including one from the performance monitoring in the CCAMP working group, and a few of them in the OPSAWG. Next, please. Oh, I think this is the last one. Yeah.
Thanks, Xiaomian. Questions? Gert, please.
Can you hear me? I think so.
Yeah.
Thanks, Xiaomian. I think it's interesting work. Looking forward, there has been discussion in IEEE, OIF, and so on about 400G CR interfaces. Do you consider them to be a client or line interface? I mean, for the audience, 400G CR is basically a coherent interface that is supposed to be point-to-point, but has a wavelength.
In this document, we didn't put this in the scope so far.
Yes.
The target is only MEF 63, and the client signal we have been specified in ITUT. But for 400ZR, it's related Ethernet configuration. We didn't touch it yet.
Yeah, I understand, and it's fully in scope, so I think it's a good work. It was just if you have spent any thought on how to move forward on such kind of interfaces that are coming up, so they're on the horizon.
Mm-hmm. I think it's a good point, and maybe we need to, if we're really taking this into account, it will impact more than one document, not only this one, but
yes,
probably the other client signal works as well. But anyhow, we need to look into that, the detail of that. So sorry, Gert, what is the progress of the 400ZR? Because we are not allowed for OIF anymore.
Can you hear me? Oh yeah.
Oh,
I
yeah.
I googled on the web that there is an OIF document out. So
So
what is the name?
the IA is released.
Yes. Yeah, it's called. Let me just look at here. Implementation Agreement 400 CR. So you can find it on the web. It's
Okay, okay.
yeah.
Okay, thanks a lot. Just one question from my side. Do you need any support in terms of liaisons towards MEF or ITU, or is anything that can be solved without it?
I think it's mainly internal work within IETF. The math is has done their job now.
Okay, very good. Thanks a lot, Tomyan.
Thank you.
Now we have the second slot. Should I?
Hi, Daniel.
Yeah.
Can you hear me?
Hello.
Oh. Hi, can you hear me?
Yes.
Oh, okay. Okay. So, hi everyone. This is Chile from ZT. So this presentation that I'm going to give is about the applicability of GMPS for beyond 100 gig optical transport network. So next slide, please. Okay. So this slide just describes the updates since last version. For the first item, okay, since this slide, okay, for the first update, it's about the OTI side. Also, it's related description is deleted as they are not in the scope of this draft. This draft is about how to operate the audio layer. So for the optical part, it's just pulling out. And for the second update, it's about how to apply GMPS to audio sync case. It's also outside the scope. So we also delete the relevant description. And for the third update, it's about the publication of the latest 709, the 2020 version. We also did some evaluation work to see if this latest version would bring any changes to this draft. So after discussing, we believe that there's no impact on this draft. The reason is because this draft is based on the 2016 version. So after this evaluation work, we added some description that the 2020 version it does not bring any impact on this draft. And for the last update, we add some description that the M value of OTUCN M, OTUCN-M, it may not be sufficient for deciding which slots are available or not. The reason is because that currently as we think that the crossing algorithm is not standardized, so we think so we have the conclusion that the M value is not sufficient. And just before the start of the CCAMP meeting a couple of hours ago, I uploaded a new 04 version. It just to reflect the changes suggested from one of the authors. I think they are purely editorial changes. Okay, this is the update. So next, please. Okay, so during the discussion, I think also believe that this draft it's pretty stable currently. So we think this draft is ready for working group last call. And also, okay, to everyone in the room, if you still have comments on this draft, please let us know. Okay, I think that's all. Thank you, Daniel.
Thank you. Thank you. Yeah. So, I mean, this has been around for quite some time, and in the end, it's an informational draft which is not defining any major extensions to GMPLS, but it's just an applicability. It evolved. At the very beginning, it was defining extensions that we realized were not needed, so it became an applicability document. I would tend to agree that all of the work that was needed is now completed, and we could consider the last call. We have Yuji in the queue, please.
Hear me?
Yes.
Okay. Thank you. Back to the previous slide, please. Yeah.
Yes.
And about the third wallet, I understood the intention. So my opinion for this wallet, since no major change after 2016 to 2020, so I would suggest the draft should be updated from 2016 to 2020 as the latest version. And so I don't think we should stick to 2016 version of DDoS709. Thank you.
Oh, yeah. Thank you, Yuji. I think it's a good question. We need to talk about this. Yeah. Okay. Probably that we will do that, I think. Thank you.
Thanks. Tatai?
Hear me? I think so.
Yep.
Okay. Okay. I have a comment on the last bullet. So you mentioned map M value may be not efficient. So I mean my question is that what additional information is needed or what are missing? I think this kind of thing should be described in this draft. Otherwise, it's not clear, right? Question two.
Yeah. Yeah. Okay. Thank you, Fateh. We added some description that to a draft that currently the information missed is about the crossing algorithm. So we don't have any standardized algorithm to operate on which slots should be discarded or not. So that's a reason that we think that M value is not sufficient for deciding this. Yeah.
So you mean this issue is relevant to ITOT specification or just how to say vendor specific?
Yeah. Yeah, it's related to ITOT specifics. Yeah.
Okay.
Okay. Next, Yuji.
The same feeling and the same comment as Fatai, and the description about crunching or for OTUCN the same. Maybe this is ITOT matter, and so for M value of OTUCN or OTUCN itself, maybe the documentation in this draft should be more simplified, is my opinion. Thank you.
Okay. Thank you, Yuji. Yeah.
Thank you. Italo?
To clarify a little bit about the value of M, yes, as Chilea is right. The reason why M is not sufficient is because it is vendor specific. So if you cascade, you don't know what are the time slots which are available. But in the draft, we clarify which information is useful, and the information will be is just the list of the time slots which are available on the two ends of the link, and instead of the M. So we have clarified that in the draft, not in the slide, but in the draft we write down that the two ends are supposed to know the list of available time slots, and how they know it depends on how you set up the ODUCN, which is outside the scope of this document. I hope this clarify the comment.
Yeah. Thank you, Ito. Yeah.
Thank you. So if there's no other question, I see Yuji, you're still, no, okay, you left the queue. Okay. Next one. Who's going to be the presenter? Sergio, Dieter? Sergio. I see you enabled the audio stream, but we cannot hear you.
Hello? Can
now
you
it
hear
works.
me?
Yes.
Oh, okay. Okay. So I'm going to present the update of the optical impairment-aware topology model, the young model for optical impairment-aware topology model, and on behalf of co-authors and contributors. Next. Okay. With the group of co-authors and also other attendees in the weekly, we have a weekly call to progress the model. And okay, we met together at CCAMP in September, so it is not passed many times. And as said in the next step, in that occasion, the topic was to finalize the transponder model, and this is what happened. So we finalized the transponder model with the version 5 of the uploaded draft, and so we updated both the young and we introduced a text, the new text in section 2.5. With this approach, so with this version, so basically we produce a young that reconcile with the different other definition related to the transponder in other layer 0 model. We have defined a new model, layer 0 type extension model, in containing all common young that should be the reference also for further document and update. And in fact, we plan to also upload the draft related to this common model, so the layer 0 type extension. And then the second, we reconcile the transponder model with what we consider a complementary work, that is the interface model containing the interface parameter young model. Next. Okay, so well, one of the basic factors for path computation is in the case of the use cases for the optical impairment is to select a compatible configuration from source and source transceiver and destination transceiver, and to determine optical signal compatibility. To make this since Singapore meeting, so IETF100, we decided to have three approach or three modes, and these three approach has been provided in the code now in the YANG, and so we support application code from the ITUT that by default guarantees interoperability, since in the parameters that are provided implicit in the specification from ITUT, they encompass also already optical path constraint. But the point is that have strong limitation with respect the state of the art of the transceiver. So they do not consider transceiver over 100 gigabit. Then there is the organizational mode, so that operators group or industrial forum can define organizational modes that permit this organization to make use of advanced transceiver capability, going beyond what are standardized in the application codes as the real words. And so the organizational mode is identified by organizational identifier plus an operational mode. And these a couple, this pair subsume a set of transceiver properties. And then there are optical power and frequency that are modeled separately, not in the presetting with the subsume parameters mentioned before. The two transceivers are interoperable if they have at least one common pair of operational identifier, organization identifier operational mode, plus they support a common range between of frequency and power. Then there is the explicit mode. So there is a list of parameters that this explicit mode is practically coming from the interface model. This list of parameters that can consistently configure the mode operation of the transceiver. In the parameters, they don't consider optical path parameters. So with this method, we cannot guarantee interoperability. But is useful in case you have not ITUT or IC or organizational mode, or the optical constraint of the application code organizational mode cannot be met by the WDM system, by the line system. Next. Okay, here is a slide that try to explain better the structure, why the structure of the organizational mode always provided. So there is we want to show the mapping of the actual structure of the organizational mode with respect, let me say, the physical of the typical optical transceiver. So we have two different blocks. So we have a part related to the digital signal processing, and in this part we have the set of parameters that are subsumed, so is implicit, in the organizational mode, in the operational mode. And then there is the optical front end that is managing power and frequency. And this is our and the preset model for related to the digital signal processing need to have an exact match between source and destination, while in the case of the parameter related to the frequency and power, we don't need to have exact match, but we need to have just a common range between the source and destination parameters. Moreover, another point regarding the fact to advertise explicitly the power and frequency is that this explicit advertising permits to support what is the real, so the fact that at the moment the optical front ends, so the pluggable, can usually have slight different power and frequency range. And so to avoid to have a proliferation of operational mode for any of these slight difference, we can manage directly power and frequency in the model to avoid that and to have the same operational mode, but with different set in the power and the frequency. Next. So this is just a summary practically. So what we said is that we have the three modes, and this is has been the purpose since Singapore meeting. The application code and the organizational mode are at style of behavior very similar. So we need to find a source and destination transceiver common set of application code or the organizational mode, and then the path computation should compute a path that can meet the requirement of one of these common application code or organizational mode. Is a similar, but the point is that application code is not enough because does not support advanced transceiver capability. So organizational mode is needed to overcome this application code limitation, while explicit mode, even if does not guarantee interoperability, but is useful in case we have no application code operational mode exist or optical constraint cannot be met by the line system. Moreover, last but not least, the explicit mode gives an alignment with the device interface model. Next. So related exactly how is done the model, so the transceiver capability are described for any transceiver. We describe all the modes that is all the modes that is supported for any transceiver, and the Young model is flexible in the sense that one transceiver can support different modes. So, for example, a transceiver might support application code 1, organizational mode 2, and explicit mode 4 and 5. The set a characteristic of explicit mode list of parameters can support theory more than one organizational mode or application code, in the sense that the set of value can be complied to 0 to n organizational mode or application code. In the model, we provide two lists with for any list or for any list of explicit mode attributes, we have a pointer to what are the application code or organizational mode that with this set of parameters you also support. So you have a complete picture. Moreover, the transceiver comprise a set of the properties that can be explicit or implicit, that depending on the modes, as explained before. And we also provide next slide. Sorry, Daniele. We provide a table that summarize the mapping for the different attributes. So we have power and frequency that are related to the attributes range of the transceiver. That is okay, everything is implicit as said by ITUT. And both in the organizational mode and the explicit mode, these parameters are explicit. For the and then there is the list of all optical impairments limit, so effect type, modulation, baud rate, etc. And these are both implicit for application code and organizational mode, and well, still implicit for explicit mode. This is just a summary in the table of the mapping between the implicit and explicit related to the parameters. Next. The model is providing in the two parts. One part is providing the description of the capability of the transceiver, and the other is the part of the setting. So any OTSI is a signal that is generated by the transceiver. The transceiver that is attached to a transponder, and so we describe the setting in the sense that any OTSI transmitter or receiver is related to a specific transceiver attached to a transponder. So for each OTSI we have 3 pointers. One pointers that provide what is the transponder instance containing the transceiver terminating the OTSI. One pointer to a related transceiver instance terminating the OTSI, and then the pointer of the currently configured transceiver mode. For any independent of the type of mode that is configured in transceiver, all the OTSI describe in the model the current frequency and transmitter power and the receive power. These are parameters and the total power. So for the total bunch of for the total spectrum. These parameters are always provided for any OTSI independent of the mode that is configured. Next, in the next slide, this is the snapshot of the model. On the left side, you can see the tree. So the first part related to the OTSI there is the 3-pointer for the configuration that is actually for the OTSI, and in the red there is the common structure for the configured parameters, so the current, power, and frequency value. On the left, you can see the structure that has been defined, and this structure are what I mentioned in the second slide, related to the extension layer 0 type extension that collect the common structure that we have defined. So on the left, on the right, you can see the structure that is common and defined in this new module. The part of capability is the part is related to the transponder. For any transponder, you have a set of transceiver, and for any transceiver, you have this supported mode, and this supported mode, any supported mode can be belong to the class of or application code, organizational mode, or explicit mode. And the other two red grouping that has been defined is one of the related to the common power and frequency range attributes, and the last one is the long list of the attribute that is explicit in the explicit mode, are all instead implicit in the application code and organizational mode that subsume all these parameters. Next. Okay, we have some in any weekly we have a discussion, and we are practically a full support of the model. By the way, we have no objection in the young model, and has been approved. There is only one issue, only one.
Sergio,
yes.
Gert put together some slides to.
Oh, yes, let me make this because this slide has been shared by any one of the co-authors, and so this is the official one in which I summarize the issue. So the organizational mode, the issue that we have treated is related to this. So there is one use case that some people in the discussion consider a corner case, in which you have a presetting some sub-parameters, but you have also explicit power frequency range, and you have also implicit parameters set up of power and frequency. So practically you have a double set. The example that I report is that, for example, if a server report that is transceiver is able to support an organizational mode X that has a frequency mean 10, but organizational mode X has implicitly also set up in their specification as in the subsume parameters as also the frequency mean, and this is set to 50. So the question that was raised during the discussion is that at that point, which value the client has to consider for path computation. one of the possible rules that has been raised in the discussion is that, the organizational mode optical specification, if the organizational mode optical specification define already an implicit parameters, the Young model should not report the same parameter explicitly. But these are in discussion in the sense that we have not a definitive answer. All this is reported in a minute of the meeting. But by the way, attendees of the weekly and the discussion that agree on the need to add text to clarify this point that is related to a priority managing in the context of the parameters related to the precedent priority in the modes. Next. Okay, here is a summary of what is the status of the open issue. Here is the link for the open issue, so everyone can have a look at that. We have at the moment 16 issues still open, but there are a couple of that this issue, this is the 4142 that is related to the transponder model, but it just require a better definition of some of the parameters. So this is an issue that was raised by Gabriele, and we expect definition from him. And it is just a slight modification of the definition. Then there is the issue related to the ITUT terminology, but it is linked to a fixed part of the terminology also in ITUT. Okay, there is a big issue, the number 23, that is related to the 3R generator. That is one of the basic plan that we have after completion of the transponder model. So now, we have as in the next step. The issue 5 and 12 have been closed because it was related to the transponder model. So we consider that as closed. And for the other issue, you can see all that in the GitHub. Next. Okay, next step. As said, basically we already start a discussion about the 3R generator, but we will need to finalize first the optical transponder model. So we plan to start immediately on the model for 3R. Obviously, we need to address the remain open issue. And important, as said before, we have planned to upload the layer 0 type extension containing the module that we have created. And last but not least, keep the draft IETF interface model align with what is contained in the topology model. So I finish my presentation.
Okay, thank you, very good. Now, before jumping into the Q&A session, I would like to give Gert 10 minutes to discuss about the modes issue. He prepared some slides to make the discussion easier to follow.
Yeah.
Gert?
Yeah, can you hear me?
Yes.
Okay.
Please.
let's go to the next slide. So this is kind of looking a little bit back on what is there on WSON and OpenConfig. WSON has a definition saying, okay, there's some future work for vendor-specific application codes, and essentially it reserves 64 bits for implementing what they call the interface class, which I think is pretty much aligned with what, let's say, something that looks like an application code is. You find the definition here below. There's also an OpenConfig implementation that basically says, okay, there's an operational mode, which is simply an unsigned integer of 16, so it's kind of a simple identifier, and that's it. So that's basically what has been before. Then, yeah, go ahead. Then there was some discussion, so up till October 26, which was when I sent out the email to the working group. We had this kind of definition in our draft, which basically says that transceivers supporting the same organizational mode and matching the same constraints, they will interoperate. So there was, at least in the definition, there was nothing about explicit parameters. Next page. So the next one was then, there was an update on November 2nd, where essentially the definition changed, saying, when you can read the full text, the thing that really changed here on the right, let's say in yellow, is to say that in addition to the transceiver properties subsumed by the operational mode, we have power and carrier frequency modeled separately, meaning kind of explicit. And the reason for that was that there were slightly different power frequency range properties for interoperability. So that's, I think, in line also with what Sergio was reporting. Next page. So that's how it looks like in the model. So you see here that there's a standard mode, which is basically an identifier. There's the organizational mode on the left with, let's say, there are two identifiers, the mode and the organization, which I think is in line with what we've seen so far. And there are other parameters like min-max frequency and power. Now you also see on the right that in case of an explicit mode, the same parameters show up. So unfortunately, I was not able to press the whole model in the on the right side. So just focusing on the frequency for now. Take it as an example. It's for illustrative purposes. So basically, we have the min-max frequency defined on two branches of the model, in the organization mode and in the explicit mode. Next one. So this is a bit about the matching logic for organizational codes. I'm trying to describe it here a little bit. So the case A is assuming that the frequency ranges would be implicit. So this would be in line with, let's say, the WSON assumption or the current OpenConfig thing. And case B is supposed to describe what has been discussed by Sergio before. So let's go through it one by one. The key point is, if you pick a single application code or mode ID, I call it mode ID because it's easier to discuss, let's say, with a name. So I said mode ID is equals 42. So that's basically the code that has the interface Y tells to the path calculation. That's the mode it is operating, and the path calculation knows its local mode, which happens to be also 42. So there is a complete match. Now there are, let's say, 4 different subcases. On the first one, the first column is they completely match. So if frequency ranges, so min-max frequency, are implicit, they need to match because you have the same mode ID, and the mode ID is defined by all the implicit ranges. So that's it. In case B, there's still the case that you need to evaluate the mean max frequency because it's external, in addition to the mode ID. Okay, second column, again, we have two different interfaces. They both report to support mode ID 42, but they have extended frequency ranges. So in case A, you say, okay, I'm not interested in any kind of extended frequency range. You just match the mode ID. Mode ID is implicit. So you're basically, oh, there's probably a typo. It should be 42. The mode ID is implicit, so it's kind of the same case as the left column. But if you really want to have the extended range, you could still do it with matching the extended range by using the explicit code. So x_range, as you see on the bottom right, is the explicit range in an explicit code. The O range, just for completion, that would be the explicit range in the organizational code. Now, if you do it the same in case B, so primarily you need to match the mode ID and the organizational range. You could also exclusive OR do the same matching with the explicit range, which is exactly what is above, and you could do a combination of both because, as has been discussed, the explicit mode has kind of a pointer to organizational code or application codes. So it could end up in, you have an explicit range defined in the explicit mode. It points to an operational code that has a different range, and yeah, so it kind of stacks up. The other column, number 3, is what happens if the frequency range of, let's say, the green and the red interface are slightly different. So in a sense, there is, let's say, the common mode that you would think that is this kind of purple square. So there's some gaps to the left and the right. The case A doesn't allow this because, again, ranges would be treated as implicit, and by definition, only the first column is allowed. The case B would allow to model it. So you have again, you can say, okay, this is my application code. That's 42, and I'm doing my matching on this orange, let's say, subset of it. Similarly, this is the right thing. It's a kind of extreme way of showing the column number 3. Again, it's the same logic. Case A doesn't allow to model it. Case B would allow to model it, and the result of the model could be there is no interoperability at all because simply the frequency ranges do not match. So that is trying to show a little bit what are the, let's say, the different matching rules or different possibilities. And next page, please. Or yeah, next page. Yeah, it's animated. So the question is, what exactly is the issue we are trying to address by saying there are slightly different input power ranges or frequency ranges? Is it, let's say, the column 2, 3, or 4? Then the next question is, okay, let's figure out what it is. That is the team proposal really clear and addresses the issue effectively? I mean, is this from a engineering standpoint really the way to go? And the other one is, whatever it is, and is that proposal that comes out of it, is it consistent with other work, or what do we need to do with the other work in order to make it match? So again, that is my interpretation, is that the change from only implicit on organization mode to explicit codes in organization mode is a pretty heavy lifting compared to what is already available. and I think it makes sense that the working group A is aware of it and makes a decision if we want to go in this direction or not. That's it.
Okay, thanks. It was clear. So the question is whether this is the right approach, and your proposal is, if I correctly understood, is to use the explicit mode only. Did I get it right?
No. Can you go back?
Yes.
So I think when we look into consistency with prior work, only the column 2 would use a combination of an implicit mode, which is this mode ID 42, and only if you want to use this kind of extended ranges, the kind of well, orange square, only in this case you need to go via the explicit mode. So think of it, okay. Make a concrete example. Let's assume an organization like, say, MEF would define a code, mode ID, which is kind of the purple one. Then different vendors may have different implementation, and they can do, let's say, an extended range in frequency and power. So that's the column 2, saying, okay, look, if you want to integrate on the purple, on a pure standard basis, you stay with the mode and that's it. If you want to use your extended capability, go with the extended range, or match the extended range and use the explicit mode.
Okay. So let's start taking the questions from the queue. Dieter is the first one.
Can you hear me?
Yes.
Very good. Yeah, I would like to point out that, as Sergio has mentioned during his presentation, we did actually agree that we should support the 3 modes describing the capabilities back at IETF 100 in Singapore. He also mentioned the rationale that was behind the 3 options. Now we have further refined the organizational mode approach for describing the capabilities. And we said, taking into consideration the physical realization of optical transponders, where in today's technology, very often optical pluggables are used, and the optical pluggables, you need to know the capabilities in terms of frequency range and power ranges in transmit and receive direction. We said that's this defined as an optional attribute on top of the organization, the operational mode, together with the organizational ID. These parameters explicitly to allow slight modifications of physical properties that these pluggable modules have. So that's also an implementation can actually decide, or an organization can decide whether some of these parameters are included in their organizational mode description, or if they should be described explicitly. So that's a very flexible model, which is also future safe and allows some variations in terms of the physical realization of the equipment. Taking the technical part aside for a moment, I also would like to point out that we discussed this point at least for 3 months in the last half a year, for at least 3 months constantly in every meeting. And this discussion is really preventing us from moving forward. And this was in a discussion that was within the group of the contributors and authors, which are meeting every week for an hour, every Thursday, and was then brought up by one individual because he seems to not agree with what most of the group has been agreed and is actually supporting. And I have no idea why we can't move forward just because of one individual constantly questioning the usefulness of the approach, which is supported by all the others in the group. Thank you.
I would I would just focus on the technical aspect because I mean in many projects that I've been working on, we realized that the things could have been done better after months. So the fact that things have always been like that doesn't mean that it's correct. Let's focus on the technical aspects.
Can I just add one sentence? I think the IETF rules is that there should be a rough consensus, and my perception was that there was rough consensus in the group before we started to continuously discuss this specific point.
That's why we are bringing this to the full working group now. If there is no consensus between the group of authors, we will see where is the consensus of the group. We will do that. Sergio.
So, no, just Daniele, since you point to the fact that to stay on the technical part, okay, this is a young model for topology, and in the couple of the first slide that Gert presented, he made some hints about the date of text related to definition organizational mode. Now, what has happened is that there has been a young model update, no, on the 27th of October, and this young model has been approved by some reviewers. By chance, one of the reviewers that approved the model was Gert Grammel. So, in that young model, as you have seen before, there is this difference related to the explicit parameters related to the organizational code. So, what is the intent to discuss again when a young model has been already committed in the GitHub? We have a lot of discussion about how to reach the agreement for the young model, and when the model has been approved by the team that is supporting and working on the draft, then raise question about the list of parameters. By the way, the fact that to have the possibility to avoid proliferation of operational mode, as I explained before, one of the reasons for which the explicit power and frequency are explicit is the fact that we have a proliferation of operational mode. There was some discussion raised by Gert exactly on the point that at the beginning of at least 1 year ago, the fact that one of the problem organizational code is the risk to have a proliferation. So these explicit parameters avoid to have proliferation, but now the explicit parameter does not work anymore. So I think that it seems that we jump behind and then ahead again, and it seems that if there is no willingness to produce something active effort, and not just try to stop the progressing of the work, okay, no one compel people to stay in a group.
Okay, Sergio, I understand the frustration of
No, it's not a frustration.
reopening.
Sorry, it's just an explanation in what happened.
Yeah, but let me finish. I understand the frustration that you see put under discussion a work on which a lot of effort has been put. The willingness of the working group is to bring this work forward. If there is an issue that has not been considered, not deeply enough by the entire team, we are here to discuss it. We will not delay the work.
No, but Daniele, sorry, there is no issue.
Sergio, let me finish. Sergio, let me finish. Today, we give the opportunity to everyone to speak up and to say, I believe that there is an issue. After this meeting, during this meeting, we likely we have a lot of time for discussion. We will do a polling. We will do it on the mailing list to give everyone, present and not present, the possibility to express their opinion, and we will define a rough consensus. This will take a few days, so we will not delay the work for a long time. Okay? Italo, please.
Thank you, Mr. Chairman. Okay, a few couple of comments. I noticed in the about the previous work on WZone, and I'm not fully familiar on all the details, but the RFC that has been mentioned by Gert is just providing a hook for vendor-specific modes, but it doesn't say too much on how they are defined. So I think here we are going a little bit doing a step forward with respect to what in that RFC is not incompatible. We just do more. And that's why I'm not sure how we can get help from that RFC, because it's leaving all the vendor specific for further study. That's the first comment. And the second comment is on this slide. I think I would like to clarify that with the current model, you will have the mode 42, which is organizational, and then you can report another mode like 43, which is explicit. And my understanding is that if you have an implicit frequency range, in the second column, you can pick up either mode 42, or in this case, you are constrained to stay in the frequency range which is defined by that organizational mode, or you can pick up mode 43, and then you can pick up a frequency range which is in the common range between X and Y. For the case B, where you have the explicit range explicit, then I understand the two cases. You either pick up the mode 42, and then you take a frequency range in a common range, which is defined in the organizational organization code, or you can pick up mode 43 and then take the frequency range in the explicit code common range. The combination of both looks very messy, and I don't understand how you can combine the two modes and make it work. Thank you.
Thanks, Italo. Gert.
Yeah, so yeah, thank you for the comment. I tried to, let's say, capture what Italo said in, let's say, those three, let's say, orange boxes later on, where the second box in case B is match explicit range, or a combination of both. So that looks a little bit messy to me as well. In any way, I would like to ask the proponents of the code, what exactly is the model or the problem you intended to solve? Is it column 2, 3, or 4?
Who wants to reply? Sergio, you want to take it? Dieter?
Unfortunately, I haven't. Can you hear me?
Yes.
Yeah, unfortunately, I haven't seen the slide before, and I was just trying to follow during the presentation what is the explanation. But what we see today is that we have in the realization of optical transponders, we can use optical pluggables, and these optical pluggables sometimes have different power ranges, slightly different power ranges, and they may also support different frequency ranges. And in order to allow the path computation function to calculate a path that takes those properties into consideration, which are not part of the operational mode, we said that those parameters should be described explicitly in addition to the operational mode. That was the issue that we're trying to solve. I have some difficulties to exactly understand on this slide because it's very crowded to which case it really matches.
Okay.
I can give you I can give you an example. Today, WDM networks are also, there's a tendency to support C and L band, for example. I mean, of course, you may actually use the same operational mode for a C band and an L band transceiver. But of course, their frequency ranges do not overlap. On the other hand, you may have also a pluggable that supports, I don't know, a power range, for example, from 0 dBm to -8 dBm, and another one that supports a range from -1 dBm to -10 dBm, for example. And this is important information for the path computation function to calculate also the optical feasibility. So this is important information that's required for the path computation function that actually makes use of the topology model, the optical impairment-aware topology model. We also defined, for example, for the ROADMs, power values for the drop ports. And so I think it's really important that this information is provided by the Yang model modeling the transceivers in order to allow the path computation function to perform its job. So that was the rationale that's behind the current approach in the current Yang model.
Okay. Gert, you can reply, and then we'll move to Julian.
Okay. Yeah, there's no question that the parameters have to be taken into consideration for the path computation. The big issue which I would like to bring up here is when do we need to use a different mode ID, and when can we use the same mode ID? So coming back to what Dieter just said about C plus L band, so that's the case on the right column, where you say, hey, I have a transceiver that operates in C band and another transceiver operates in the L band, but they're using the same mode ID. So in my view, that's not a very wise decision. They should use two different mode IDs, like depicted in the first row. Because
May I quickly reply?
Yes, sure.
I mean, that's one possibility. An implementation can decide to do it one way or the other way. The Yang model is flexible enough to do it both ways.
Exactly. So if the point is whether I should use mode ID 42 plus some extensions which are allowed by the model, or I should find a mode ID 43, I think this is outside our scope. We provided the tools to encode the information. Then how it's encoded, this should be left to the producer of the transponder. But this is just my opinion. Let's hear from Julian.
Hello, this is Julian Maric. Can you hear me well?
Yes.
Okay. Actually, Daniele, you almost summarized the point I was about to make, so thank you for that. Yes, indeed, I feel that the current model as a contributor is flexible enough to accommodate various ways to describe the hardware and software capabilities. There are some flexibility to pair implementation or implementation-specific description, and it's future-proof to enable the support of new capabilities that may not be fully described in implicit mode so far. And has a drawback, as it is for various other specifications that we may have in the IETF. There may have some wrong ways to use the open fields, because you may, in many protocols, carry two fields who could carry opposite information. So obviously, there are bad ways to use protocol specification, but here the idea is to be able to describe a wide range of possible hardware. I feel the model with the various specification mode is fully fits this requirement and unable to describe various things. And here on the current displayed slide, I'm really confused, and I think I'm fully aligned with Italo on Dieter on that, because it feels to me that the mode here is badly used and it's referring to different things, and clearly they shouldn't. Either it's 42 taken for different spaces, so in fact it's not the same 42 and they don't collide, or either if it's the same numeric space, there shouldn't be 42 in all cases. So it feels to me that here it's not a clear problem statement, and probably a way to address it is not to change the specification, but maybe to add some clarification text or guidelines to mitigate the wrong use that an implementer may be tempted to take if they're not familiar enough with the model. But I feel the model is large enough to accommodate various needs, and for me, it's the way to go.
Can I ask a question to Liang?
Yes.
Sorry. Yeah. So I understood that you, let's say, would support that the model supports also the column, let's say the two last columns, where I say, okay, I'm using the same mode ID, but let's say frequency range or power range have a kind of a dead zone, however big that one is.
And maybe it's pointing to a missing clarification text in the document and nothing more.
Well, I think the question is, are we going to support the kind of a dead zone in a mode or not? I mean, if we can strike out the two right columns, saying this is not allowed, one way or another, we stay with the two columns on the left. But if the idea is to say, no, we want to support those kind of dead zones, let's say non-overlapping zones, and use the same mode ID, it's a different implementation then.
Yeah, on this one, I feel the need to point to Italo's presentation that he shared a couple of weeks ago within the group, and I think it's deeply linked to that. And if you feel there is some unclear spec, we may give some inputs in the draft, but I don't think it's a modeling issue. It's a guideline.
Yeah.
Missing guideline maybe, but not modeling issue.
Let's say for me, the first question is, what is the problem we want to solve? So do we want to solve the two right columns at all? Or do we say, okay, we simply forbid it one way or another and focus on the two left columns?
Well, to me, the two right columns don't describe a problem statement clearly enough to give you an answer. The mode ID is supposed to be attached to an organizational code. If within the same organizational code there is the same mode ID pointing to two different things, there is something wrong already before going down. So it's confusing. This table is really confusing to me.
Okay, we will take now the question from Omian, Sergio, and then we will wrap up because we have another presentation to take. Omian, please.
Yeah, thank you. I'm also trying to understand this table. It seems on the same page of slides on the left top corner, the mode ID 42 has a list of parameters with some quantitative values. It is too small to read, but I'm just trying to say it's not a modeling problem, but it's a kind of implementation. And people just confused on, okay, who is specifying this kind of value? Oh, if this is editable, could you extend the? No, you can only extend the green table. Daniele.
What is the green table?
On the top left.
Green table on the top left.
No.
Yeah, with model ID 42. Oh yeah. Okay, it's a list. Okay, then the question comes to who specifies this quantitative value, because I think most of them are quite numeric and have the impact on those kind of quality of transmission. So if a specific mode ID is a kind of representation of so many parameters behind, I think it is questionable because these parameters will impact the interoperability between the two transponders. So we need to know, okay, how to use the mode ID in the organizational mode, because I don't see the debate on the application code or explicit mode, because everything we can tweak or everything is fixed. But for organizational, it's quite flexible, and if we still want to guarantee the interoperability, we need to be very carefully on determine the value in such a table.
Okay, thanks for the comment. Sergio, and then, sorry, Dieter, but we needed to cut the line after that. You wanted to wrap up and then move to the next. Please.
I have just a short comment that probably before in my presentation I forgot to say that the explicit parameters that you have in organizational mode are also optional. So because the model is very flexible, and so the fact that you can use one implementation can use that or not is just an implementation problem, not a problem of the model. So this is a clear point that probably I miss in the presentation. So frankly speaking, I think that what Julien said is that a text that can clarify possible problem in the precedence, provided that, frankly speaking, the table provided by Gert, for me, is very confused. So I'm not able to judge that based on these slides. But the discussion we had in the weekly, we already provided the need to have a text that clarify the precedence pointed out by Gert this morning. So it's nothing that has not been already discussed.
Okay. So I said we would cut the line, and the line is populating. But you have the priority if you wanted to say something. Otherwise, we wrap up.
So I have just one quick comment. So could you go back to Sergio's slide and go to page 5?
Sergio slide, page 5. This is difficult.
Yes. Oh, really? Yeah. Page 5. Yeah. So actually, in this page, it says that it mentioned, one of the coming for application code mode, and it says application does not support, beyond 100G capability. So my comment is that, so shall we, shall we as ITOT members go to, ITOT, bring some contributions to ITOT to define the applications for beyond 100G, and then we can go back to IETF to define the, young models for the optical impairment, especially for the beyond 100G. Is this feasible?
Not to me. This would delay things by years.
Yeah. So my just comment to Sergio. And so what's the issue? If this is the issue just, from ITOT recommendations, anyway, I think we should fix this issue in ITOT, right?
Okay, so let me try to summarize. First of all, thanks for the discussion, because this was really useful, and it needed all the time to sort this out. I think that the way forward is to send out a polling to the mailing list. We will give 1 week to reply, not more than that. The options that I was thinking on while you were speaking were: option A, leave everything as is; option B, add the text to the draft describing the scope a little bit better, which means if there are possibilities in that we don't want to cover, we explicitly say these use cases are not covered by us. Option C, go back to ITU to have more application codes that can cover all the cases. Option D, I would ask Gert to send me his proposal for option D, if there is an option D. Everything by Monday, if possible, because I would like to send out the polling on Monday and close it by next Friday. Fatai, you have the right to say I disagree with you. I added option C because you said it, but I would really like to.
Daniele, actually, I agree with your suggestion. Yeah, it's fine for me.
Okay, very good. So, Gert, if you have a proposal for option D, please send it to me
Sure.
by the weekend, and on Monday I will send the 4 options to the working group for decision, to find an agreement by the end of next week. Thanks a lot, everyone. And we now jump to the last presentation on OTN slicing. It's less than the 20 minutes allocated, but it's 2 minutes more than the 10 asked. So it's still a trade-off.
Hello.
Please.
Can you hear
me? Yes.
Okay. Hi. So my name is Iwar Guo, and I'm from FutureWe, and I'm here presenting this new draft framework and data model for OTN network slicing on behalf of all the co-authors and contributors. Next. So an OTN network can provide hard pipes with qualitative service such as deterministic latency and bandwidth. Right? And here we are looking at providing OTN network resources to support OTN specific use cases. For example, we're talking about supporting leased line services with OTN, in which customer typically like an over-the-top provider leases one or multiple point-to-point OTN connections to connect its data centers across the network. Second use case is co-construction and sharing of OTN network, where multiple service provider can build the same OTN network in order to save cost. And each of the service provider in this case shares and uses network resources, and their resources are kind of isolated from each other. And in the third use case, we have a wholesale of optical resources, where one service provider serves as an OTN wholesaler to provide OTN network resources to another service provider. And the other service provider would expect to be able to use the purchased network resources just like they are self-constructed. The last but not least use case is vertical dedicated network in other industries like financial industry or manufacturing industry, where people are asking for dedicated OTN network to satisfy some stringent network conditions like deterministic latency and non-jittered bandwidth. Next. Yeah. So what is an OTN slice? So an OTN slice is just a collection of OTN network resources used to create logically dedicated virtual network over one or multiple underlying OTN networks. So for an OTN slice, some of the SLOs of an OTN slice must be expressed in an OTN specific way. For example, the bandwidth is expressed in terms of numbers and types of ODU and OSU. ODU time slots, and OSU is a new term for smaller and flexible granularity of OTN time slots. And if we are talking about specific OTN time slots, we're talking about in terms of the tributary slots and tributary ports. So other definition of the SLOs, those generic SLOs can follow the definition. I think I'm missing some words here. Can follow the definition coming from the IETF network slice discussion in the TIS working group. And the current relationship with the IETF network slice YAM model, the one that defines a generic network slice using network topology. That one is for some further investigation. As also going to show in the later slides, it's possible to augment the model and add OTN specific information. Next. So this is the picture of a where we are defining OTN slicing function in the whole picture, and as well as the placement of the model. So we see there's a OTN slice controller called OTN-C that can be either placed inside an SDN controller as a internal function of an SDN controller, or it could be as a separate function box outside of the controller. And if it is placed outside of the controller, the OTN slice controller will be translating slice configuration from a high-level orchestrator into a technology-specific model using, for example, T topology and T tunnel, and talk to the SDN controller. Whereas if it's inside an SDN controller, it can use internal API to talk to a PNC, which is out of scope of this draft. And please note that in this whole picture, we're talking about the request for an OTN slice coming from the user for OTN specific slice requests. Right? So the interaction, the OTN slice could be hierarchical, meaning that one OTN slice controller can talk to yet another OTN slice controller in a recursive manner, using the same interface. So next slide, next page. So there are two modes for OTN slice. One is what we call link-based slicing, in which a link and also its ports are dedicated to a single OTN slice. And in the second case, we could actually create an OTN slice using some one or multiple time slots, tributary. That's what we call tributary slot-based slicing. Next. Right. So currently, we are defining the young models, and the updated model will be coming out in the next version. And as I said before, the authors are considering augmenting from the IETF network slice young model to add OTN information for configuring the OTN slice. That's the next step, to come up with the young model definition. And also at this point, we're more welcoming comments and also looking for co-authorship of this draft. I think this is the last slide. Thank you.
Thanks a lot. Fatai, are you still in the queue since before, or you're in the queue for comments to this presentation? Okay, I think we can go with Adrian if you wanted to ask.
I should leave the queue. Yeah.
Okay. Adrian.
Yeah, thank you. Try to be really quick on this. Firstly, it would be helpful to put this document in context of the work being done in TEAS, rather than defining new stuff. Do the authors expect any deviation from the terminology and framework that TEAS is working on?
Okay, so I think the the framework would be in line with the TEAS draft, but because the use cases we are looking at is more from a OTN perspective, so we're hoping to augment or add more OTN technology specific requirement into the slice definition.
Okay, yeah, that sounds reasonable. The other thing I draw your attention to is there's a document that's been discussed in TEAS on the applicability of ACTN to slicing, so that may be relevant for you.
Yes, we are aware of that. Thank you very much.
Thanks, Adrian. And this brings to my question, which is in what an OTN slice is different from an OTN service? I mean, I see this can be like a number of OTN tunnels stitched with each other. So in the end, it's an ACTN virtual network. In what is different from that?
Yes, this is one type of OTN slice, but we are more looking into what do you call it? It resembles like an ACTN VN type 2, which is a resource slicing, right? that forms a virtual network that can be used to for the client to set up connections on the sliced network.
Okay, thanks.
Yeah.
Yuji.
Please clarify the scope of OTN itself. What do you mean by OTN here? And the reason is that it includes OSU at the new discussion in IETF. So OTN of the 709 related or the something other or more? Thank you.
Yes, so the OTN we're describing here is the OTN optical transfer network as defined by IETF 709, as well as the new development of the optical service unit, also defined in IETF.
Okay, Sergio, last question, and then we close the meeting. Sergio?
Can you hear me?
Yep.
Okay, so thanks, Iowa, for the presentation. There are a lot of interesting things in there, but I have a need to clarification. Following the design team of the slicing, so one of the basic points has been addressed is the separation between definition of the slice and the realization. So is it a real need to define OTN as you define OTN slice? Well, for me, OTN slice is the realization of a slice based on some requirement for which transport slice controller decide that the best technology is the OTN. This is making a parallel with virtual network. We have not defined OTN virtual network. Is a realization, no?
It's not just a realization in my view, because we are in this case, right? The requirement from all the way from the top is to specify which OTN resources or what type of OTN resource is needed for the slice. So it's not just say you come with a generic network slice and that the realization will be carried over an OTN network. This is one scenario, but we are talking about another one that says the customer expresses its slice in terms of OTN resource requirement.
Okay, Italo, keep it short.
I will try to reply to both Sergio and to some extent also to Adrian. Actually, that's exactly why we were a little bit struggling with the alignment with the design team in TIS. The reason is that in some cases, the OTN slice may be implemented to realize a generic transport slice as defined in TIS. In other cases, may be used to offer a service to the customer. In this case, the CMI is also OTN technology specific. The customer is requesting the operator and an OTN network, and that's another use case that we have seen and that can be addressed by these models.
Okay.
Okay. Thanks a lot, Italo. Thanks a lot, everyone, for the good discussion. We learned that no matter how much time we ask for, we always manage to fill it, which is good because it means that there is a lot of interest and energy. And so I will wait for option D from Gert. Please remember to check the polling next week on the optical impairment draft. And that's it. Let's meet again virtually at IETF 110. Thank you, everyone. Bye-bye.